Good evening and welcome to this episode of One Man and His Whiteboard.
Tonight we're going to talk about ACLs and bits. Primarily, our focus is going to be on not teaching access control lists, but how we can selectively choose different bits within the access control list. We have other videos that cover standard access control lists. Just want to make sure we all understand bits and binary are used in IP version 4, and it's very similar in IP version 6. Tonight we're going to talk about IP version 4 though. The main reason, or the main way we use them, is defining a network like 10.1.2.3, and then we declare a mask of 255.255.255.0. That mask is actually in decimal. If we convert that mask over to binary, we should see that 255 in decimal equates to 1, 1, 1, 1, 1, 1, 1, 1. Whenever I write binary, I like to leave a little gap in the middle. I write them in sets of 4s. It's easier to distinguish them. And of course, 0 is represented as 0, 0, 0, 0, 0, 0, 0, 0. Nice and simple, right? So 255 is made up of 8 ones and 0 is made up of 8 zeros. That's simple. So another way of representing this mask, which I seem to have implied is 255.2 space 55. Let me just, there you go. Another way of writing this is counting the number of ones. So in the first 255, there'll be 8 ones, and 8 ones, and 8 ones. So we write that down, of course, as /24. Okay. So in this situation, the 1 represents something we care about, a network portion, where the 0 represents the host portion. So here we can clearly see by using a network mask, that's actually supposed to be network. My little mouse ball is misbehaving. So we have network bits where the 1 defines the network and the 0 is the host. So from the networking perspective, the 1 is of interest and the 0 we ignore. So from networking, you check the 1 and you ignore the 0 from the perspective of networking. So we can bunch together networks. If we wanted to use all the subnets of 10.1, we could just simply say 10.1, and by convention we put a 0 in if we're talking about a network, not a host. And we could say /16. And that will represent, of course, in decimal, 255.255.0.0, which is nice and easy because we do it on a byte boundary. But what if we wanted to talk about networks 10.16 all the way through 10.31? So we want to create a network summary of 10.16 to 10.31. Well, what we do to start off with is we write 16 down in binary. Then we write down 31 in binary. And then we take a look at what they have in common. Well, 16 and 31 have that in common. So we could write down a mask talking about the networks 10.16 through 10.31. Our mask would be check these bits and ignore these bits. So that would be a summarization of 10.16 through 10.31. But what number do we put in? Well, by convention, we put in the first number and we zero out all the ignored bits. So that represents 16. So we'd say 10.16.0.0 255.1111 is 240. So 111000 is 240.0.0. Or we could also write down the 8 ones from here, then there's 4 ones in there, so we could say /12. So by identifying commonality, we can summarize a series of networks. Now that's how networking works. Access control lists do the opposite. If you want to check an ACL, you put a 0 in that space. If you want to ignore that bit position, you put a 1 in that space. So under networking, 1 is check, 0 is ignore. 1 is the network, 0 is the host. Under access control lists, 0, we check the bit. 1, we ignore the bit. It's the opposite way around. So if we want to look at all the hosts on network 172.16.1, 172.16.1 network, by convention, we zero out the host field. If you want to check all the hosts, so you want to apply some rule using an access control list to all the hosts on that network, we'd use the address of 172.16.1.0, and the mask we would use is 0, 0, 0, 255. So we put 1s to ignore the last field. If we wanted to write an access control list that applies to 10.16, so block traffic or permit traffic if the network is on 10.16 through 10.31. Okay? Again, we have to find the commonality. There's 16, there's 31. Oops. 16 is 0, 0, 0, 1, 0, 0, 0, 0. 31 is 0, 0, 0, 1, 1, 1, 1, 1. So again, find out what's common. So now we put zeros in the wildcard mask. Networks use network masks. Access control lists use wildcard masks. They have a different name because they're the opposite. And we ignore these last 4 bits. So now, by convention, we use the first one, zeroing out the bits we ignore. We'd say 10.16.0.0, and the mask would be 0.0.0. 1111 is 15.255. Okay? A bit of nastiness there. Let me just tidy that up. So 0.15, I seem to not be able to get my numbers straight today. .255.255. Okay, guys, I'm going to clean this up a lot because it looks like 295. So 0.15.255.255. So you ignore the last 20 bytes. You only check the first 12. The 8 in the first number, and then the first 4 bits. Did I say bytes? I'm sorry. You ignore the last 20 bits. You only check the first 12 bits. So now you see how you can use wildcard masks with access control lists in a similar way to we use network masks to do summarization. But you may be told that you need to pick 2 networks out of 3. Let's say that we are told that we have network 172.18.0.0, and we have network 172.67.0.0, and we have 172.128.0.0. You may want to create the most efficient mask you can to block 172.18 and 172.67 and to allow 172.128 through. So our mission is to write the most efficient access control list we can to block 172.18 and 172.67. And it looks like a horrendous job, but first thing we have to do, stop thinking in decimal and convert to binary. So 18 in binary is basically 16 with the bit position of 2 set. What's 67? Not looking good. What's 128? And it's very important to master this. You have to be able to do the binary conversion. Now, doing the skills that we've used so far, it doesn't look there's much hope. But if we look a little bit deeper, we see something very important. We've been told to block 2 things and allow the other. Well, there's 2 ways we can approach this. We can either notice that they are both 1, and that is not a 1. So we could either permit the networks with the 0 in that position, or we could block the networks with the 1 in that position. Now, because we only have 3 choices, we can do this. If you think about this, if we block all the things with a 1 in this position, we will block 2, 6, 14, 10, 67, 131. They all have this position set. But because we're given this set of 3 and told to do something, it's quite safe in this restrained example to do this. I never ever said to you, look at the 1 there, because we were clearly told to do something with 16 through 31. Well, only 16 through 31 have all these in common. We were told to summarize 16 to 31. Only 16 to 31 have this number range, these 4 bits in common. It's very bad practice to do network summarization or to do an access control list in the real world, including more things than you actually want to include. But in the example here, we've got a clear mandate that we want to create the most efficient access control list possible for the only 3 networks we own. Okay? So in this situation, it's okay to restrict it to this, but be careful. If I create the access control list I'm going to show you in a minute, which says block everything that has a 1 in bit 2 position, it will block everything that has a 1 in that position. As I mentioned, 103, 255, 3, 14, and so on. Okay. So what we do now is we look at what we want to check, and we make that the 0. So the match is a 0, and all other bit positions have a 1. I want you to ignore all the other bit positions. I don't care what they are. Okay. And as always, we look at the basic number. Now, because these are all ignored, we zero them all out. So you zero out everything you ignore. And that is going to be the number. So we will say, look for any networks, and the first field, of course, is going to be 172. We want that to be true. So the first field is 172. We put a 0 in the mask for that, because you want to check every bit there. Then we put down the number 2. Then we zero out the rest because we don't care about those. Then we put 255 because we ignore the 3rd byte. We put 255 because we ignore the 4th byte. It's the 2nd byte we have to work out. Now there is the mask for the 2nd byte, and if you do the sums, do the maths, that becomes 253. So if I create an access control list saying deny 172.200 with a mask of 0, 253, 255, 255, it will block any information coming from any networks where that bit is a 1. And because of these 3, only these 2 match. What happens basically is these 2 are blocked, that one is allowed. So that's how you create the mask to do that type of bit manipulation. So simply, we can do networking with bit manipulation. We can do simple access control lists by ignoring entire bytes or parts of bytes, or we can use access control lists to do things by looking at whether a single bit or a series of bits are set. And that's basically it on ACLs and bits. We'll see you next time.